Alright, Chapter 3 Summary. Before going to the next chapter stated below, let's be sure that you understand the important points of the chapter. Electrostatic field. When a charged body that is brought close to another charged body, the bodies either attract or repel one another. The charges are likely to repel, and the charges are opposite. They attract or repel. The coefficient is called the electrostatic field. The amount in which two charges attract or repel each other depends on the side of the charge. Distance between the charge of the electrostatic forces being two charged bodies may be represented with a line of force. Draw a perpendicular charge. Serve with the electron placed in the field and move toward the positive. Alright, and capacitancy is a property of a circuit which opposes any change in the circuit voltage. The effect of capacity may be seen in any circuit where the voltage is changed. The capacitation is usually defined in the ability of the circuit to be electrical energy. Energy is an electrostatic field device. Electric current is the charge. The storage charge is an energy is called the capacitor. The basic unit of the measurement is called the farad. 1 farad capacitor. 1 farad capacitation is the store of 1 coulomb in charge or one potential 1 volt across the capacitor plates. The farad is normally large. The farad is an enormously large unit of capacitation. More practically used the microfarad or the microfarad. So capacitation opposes any change with the circular value. Voltage, capacitation, voltage increase the capacitation tries to hold it down. Voltage and capacitation. When voltage decreases, the capacitation tries to hold it up. Alright, capacitation. Capacitor is physically device consisting of two pieces of the conducting material separated with the insulating material. The insulating material is referred to dielectric. This becomes the dielectrical insulator. No current flow through the capacitor. The dielectrical breaks down and becomes the conductor. Capacitor no longer holds the charge of the useless. The ability of the dielectric to hold the charge of the breaking down is referred to as dielectrical strength. The measure is the ability of the dielectrical material to store what is called the dielectrical constant. Dielectrical constant is a relative value based on 1.0 vacuum plate dielectrical electrical nucleus distorted or normal orbit plate 1 switch 1 plate battery. Alright, capacitors in DC circuit. When a capacitor is connected to the terminals of the battery, each plate with the capacitor becomes charged. The plate is connected with the positive terminal loses the plate with the connected to the positive terminal loses electron. The plate this because of the lack of the electrons assumes a positive charge. The plate connected to the negative terminal gains an electron. Because the plate has an excessive electron assumed with the negative charge, this process continues until the charge across the plate equals applied voltage. At the point current ceases to flow in the circuit as long with nothing changed in the circuit, the capacitor will hold the charge and thereby with no current in any part of the circuit. The leads for the capacitor are now shorted together and current again flows over the current. Current will continue to flow until the charges in the two plates become equal. At this point, the current ceases to flow with the DC voltage source. The current will flow with the circuit only long enough to hold, charge, or discharge the capacitor. Thus, the capacitor does not allow the DC current to flow continuously in the circuit. Alright, so when it's uncharged, the capacitor is collecting negative, and then charging would be when the positive negative is going through to the positive, and then the flow of the negative electrons. Notice that the capacitor does not allow DC to flow continuously in the circuit. Okay, so circuit charged. You have a rectifier and voltage rectifier, voltage cloud, and voltage total voltage in the circuit. Switch 1, switch 2, circuit. Factors affecting capacitation. There are 3 factors affecting capacitancy. Factor of area of the plate of surface that increase the area of the plate, increase in another factor of the space between the plates. The closer the plate, the greater the will of the electrostatic field. The greater electrostatic field cover, the greater capacitance of the place in the plate spacing determined by the thickness of the electrical third factor affecting capacitation. The dielectrical constant, the value of the dielectrical constant depends on the type of the dielectrical used. Working voltage of the capacitor, maximum voltage that can be steadily applied to the capacitor. Thus, the capacitor breakdown shortening. The working of the voltage depends on the type of the material used. The dielectrical constant thickness of the dielectrical capacitor losses. Power loss from the capacitor is called the dielectrical leak or dielectrical hysteresis. Dielectrical leaks is called the leak over the current with the resistance in the dielectrical. Although the resistance is extremely high, a small amount of current does flow. The dielectrical hysteria may be defined as the effect of dielectrical material similar to hysteresis found in magnetic material. Alright, RC time constant, time required to charge the capacitor is 63.2% applied with the voltage discharge capacity of 36.8% of the charge. Total constant is equal to the product of the resistance and the capacitation expressed in the time in seconds over the ohms over the farads. Show the percent of the charge in the 5 intervals, constant intervals of the RC charge and discharge capacitor in series. Effect of the wire capable of the capacitors in series. Increase the distance between the plates. Reduce the total capacitation and the circle the total capacitation of the series is connected to the capacitor computed as capacitation is 1 over the 1 over C1 plus 1 over C2 plus 1 over C through and continue in the series of the number of capacitors in the series. Show that the C2 is equal, C capacitor tolerance is equal to C1 plus C2. In the electrical formula, the only two series connected capacitors capacitor 2 may be computed as the following formula. Capacitor 2 is equal to C capacitor 1 times C capacitor 2 divided by C1 plus E2. Capacitors in parallel, capacitors in parallel, affecting the wire capacitor parallels increase the effect of the wire capacitor parallels increase the plate with area with the capacitor. Total capacity may be found by the capacitation total plus C1 plus C2 and plus the number of capacitors in the parallel. Alright, type of the capacitor. Capacitors are manufactured in various forms. They may be divided into two main classes: fixed capacitor, variable capacitor. Fixed capacitors are constructed with a heavy constant fixed value of capacitance. Variable capacitors allow capacitation to be varied and adjusted. And that completes Chapter 3 summary.